Don't forget to subscribe and ring that bell.
Welcome to the third video for the January 2023 Algebra 2 Regents High School exam. Video 1, we did problems 1 through 8. Video 2, we did 9 through 16. If you didn't need those because, hey, you a boss, that's fine. We're about to do the third leg, 17 through 24, which is the last of the multiple choice problems. And if you have 3 legs, I suggest you see a doctor and get some medical attention immediately. That's not normal. Let's go. And as I previously mentioned, this is the last of the multiple choice problems. They are worth 2 credits each. You don't get any partial credit. Just pick an answer. Well, I mean, hopefully you can calculate an answer, but you get my drift. My, oh my. For which approximate values of x will log of x plus 5 equal the absolute value of x minus 1 minus 3? This test, we've used the calculator a good amount for. So you better know how to use the calculator, what you can use it for, because if you don't, you are leaving points off the table. All right? I'm going to graph into y1. Let's go here and make sure I get the thin one. There you go. I'm going to put this into y1, and then I am going to put this side into y2, and I hope you know where the absolute value is in the calculator. If you don't, make note, kids. All right, turn this on. On one more time. I guess we got to double tap that. I don't know. There you go. Oh, green. Such a good color. So for y1, I'm going to put log. I do not have to do log base. There is no base there. It's 10 if it's not written by default. So yes, you don't have to hit log base. You can just hit log. X plus 5. Boom. And then I'm going to put math. If I move over to num, it's the first one. ABS is not anti-lock brake system. You'll learn that when you get cars, kids. It is absolute value. And in the absolute value bars is x minus 1. Make sure you pop out of the bars to do the minus 3. I'm going to graph these and see where they intersect. Okay, there's my first log graph. Thanks. There you go. 1 intersection and 2. Okay, if you don't know where the intersect function is, you're going to press second, which is the blue button, and trace. And I'm going to pick intersect. We'll do this twice. Boom. You see my little spider dude that's kind of flashing there? I'm going to move him left. If you have 2 intersection points, okay, just you don't have to get right on it. I know it looks like I'm right on it. But you just have to get close to the one you want and hit enter 3 times. 1, 2, 3. The first answer, if I look down here, is negative 2.41. Okay. Now, if I want the second one, I've got to do this all over again. What do I mean? I have to hit second trace again and hit intersect again. And this time, I'm going to move closer to the other intersection point. Hit enter 3 times. 1, 2, 3. The other answer is 5. So you have negative 2.41 and 5. Oh, look, choice 3. Negative 2.41 and 5. Number 18 is tricky. Okay, consider a cubic polynomial with the characteristics below. It has 1 root, and then as x goes to positive infinity, or that means as x goes to the right-hand side, because that's where the positives are on the x, my y is going down or to the negatives forever. Okay, it is cubic, which means my degree or my biggest exponent needs to be 3. Okay. And they say, given that a is greater than 0 and b is greater than 0, which equation represents the cubic polynomial with these characteristics? All right, first and foremost, my x's, as they go to positive infinity, that's to the right side. And my y's, as they go to negative infinity, that's down. So I know that a cubic function, they go in opposite directions, which means if I'm going down and to the right, like it's telling me right here, The other side has to go up and to the left. But here's the thing. Is this connected? It is not. Let's do this so it's one connection. So it's easier to move. Okay. Here's the thing. Like this, down. Like that. Okay. Okay. So I don't know. I mean, it could look like this. I mean, if it's degree 3, it should have 3 answers. It should touch the x-axis at 3 points, shouldn't it? It should. But look what the first bullet says. This is exactly 1 real root, which means it's only going to really touch the x-axis for real only once. It's going to look like this. So let's take a look at our options. And I'm noticing right off the bat, okay, if I multiply my x's together, x to the 1 times x to the 2, well, that's going to give me x cubed, degree 3. This one will as well. Actually, why don't we take it a step further? The first one will give me a positive x cubed. The second one, if I multiply a negative x times a positive x squared, it will give me negative x cubed. All right. This one, x squared and x squared, that's x to the 4th. That's a degree 4. I don't want that. Remember, we want a degree 3. That's what cubic is. Okay? And this last one, okay, I have a positive x and a negative x squared. Okay? And that will give me a negative x cubed. Right? So this is where the arrowheads come into play. For anything that is positive x cubed, it would look like this, down to the left and up and to the right. Okay. If it's a negative x cubed, it would look like how we drew it here. Okay. So I know it's got to be negative. If it's going down and to the left, it's got to be negative x cubed, because if it's positive x cubed, it would be going up and to the right. So I know it can't be number 1. It can't be positive x cubed. So let me get this out of the way. So much that I got to move. So I've really got 2 choices. It's either 2 or 4. That's where my 1 real root comes into play. If I solve for this right here, and I solve for this right here, okay, set this equal to 0, my x would equal a. That's 1 positive root. Here, okay, my x would also equal a. That's 1 positive root. This is a DOPS. This is a difference of perfect squares. I can get 2 real roots here. I can get 2 real answers. Okay, because I can factor and solve a difference of perfect squares. This is a sum of perfect squares. I cannot solve this. This is going to have no real solutions here. They are only going to be imaginary. So I'm going to have 3 answers here. I only want 1 real answer. Here's my 1 real. The rest don't work because they're imaginary. It is choice 2. There was a lot to comprehend with that problem. That's why I said this is a tricky, tough one. All right? But now you know. 19. Number 19 reads, Betty, good for her, conducted a survey of her class to see if they like pizza. She gathered 200 responses at 65% of the voters said that they did like pizza. Betty then ran a simulation of 400 more surveys, each with 200 responses. Assuming that 65% of the voters would like pizza, the output of the simulation is shown below. Okay? So we look at all these dots. Each dot, this dot right here, this dot right here, this dot right here, this dot right here. Each one of those dots represents a separate survey of 200 responses. Okay? That's crazy. Okay? The bottom says below the graph, consider the middle 95% of data. What is the margin of error for the simulation? Let me explain something. And I'm going to explain something that has a little bit to do with the problem, but is more likely to see later on a test at some point. When they tell you 95% of the data, 95% covers everything that's considered a normal occurrence. I call it in my class the moneymaker. When I say, hey, kids, what's the moneymaker? They know that's 95% of the data. That 95% covers, it starts the mean, that's the mean, that's smushed M is the mean, and you add and subtract 2 times the standard deviation. Okay? So my mean is given right here, 0.654. And then I add 2 times my standard deviation, which is 0.035. And I also subtract it. That gives me the interval that covers 95%. So we're going to do this math here for 1 second. Turn this on. Clear this out. And we have, okay, 0.635, okay, plus 2 times 0.035. Okay. Did I do that right? No, it's 5.4, not 3.5. So I go here, and it's 5.4. My bad, kids. So it's 0.724. All right? And then I subtract the same thing. And it's 0.584. So 0.724 to through 0.584, 95% of my data is within here. This is what's considered normal. Now, why did I show you? That is going to pop up at some point in the test. It always seems to. So what about this margin of error? Margin of error is simply this part of it. I take 2 and I multiply it times 0.035. And if I do that, I get 0.07. That's my margin of error. So Visca, why'd you go ahead and show me it? Because it's important. It typically shows up on the part 2s, and I wanted to throw that out there. But my margin of error is 0.07. You're welcome, because you're going to see that later, and you're going to thank me later. Number 20, cosine, trigonometry. A is for awesome. The cosine of A equals radical 5/3. And the tangent of A is less than 0. This right here is telling me that tangent is negative if it's less than 0. What is the value of the sine of A? All right, well, I'm going to do this right here. Be nice if that actually listened to me. And by listened, I mean responded the way with the color I wanted. So my cosine here is positive. My tangent is negative. Okay? If you know anything about trigonometry on your set of axes here in the unit circle and all that jazz, you know that all students take, we'll say calculus or cookies, go nuts. These letters tell me what quadrant which trig functions are positive. They are all positive in quadrant 1. In quadrant 2, sine is positive, and that means cosine and tangent are both negative. Okay, I want my cosine to be positive, so it's not in this quadrant. Okay, I want my tangent to be negative, so it can't be in quadrant 1 because they're all positive there. Okay, well, tangent, quadrant 3, which is telling me the tangent is positive. Sine and cosine are negative. I mean, that's not what I want. I want my tangent to be negative, so it's not here. So guess what? Quadrant 4, my cosine is positive, my sine and tangent are negative. So here we go, we got a checklist. A positive cosine, a positive tangent, quadrant 4. So I'm going to draw this angle. If it starts here, again, it'd be nice. You see here, I tap the blue, see how it's dark? So I got to go here, hit the arrow. I got to go here. Let's do the blue. My angle is going to be somewhere here. So if I draw a triangle, a right triangle, here's my angle. Okay? Cosine, which is adjacent over hypotenuse, right, kids? The hypotenuse here, Let's go here. Cosine of my angle, which is adjacent over hypotenuse, is radical 5 over 3. Where am I getting that? Right here. So my adjacent side is radical 5 to this angle. My hypotenuse is 3. They want to know what the sine of this angle is. Well, sine is opposite over hypotenuse. So sine of angle A, it still uses the same hypotenuse, which is 3. I just got to know what's the opposite side. So I'm just going to use the Pythagorean theorem. Got to love it. A squared plus B squared is C squared. Radical 5 squared plus B squared is 3 squared. 5 plus B squared is 9. If I subtract 5 from both sides, B squared is 4. I hope you know it's 2 squared. That's 4. But if you want to be all warm and toasty and do this, your B is going to be 2. So I know my opposite is now 2. So I put 2/3 here. But before you start circling choice 1, remember when we started this whole thing? Quadrant 4. Cosine is the only positive value. Isn't sine negative there? It is, children. It is. So you better make this fraction 2/3 negative. Oh, they tried to throw one past you. It's negative 2/3. But you're too smart for them. You got this. 21. A tree farm initially has 150 trees. Each year, 20% of the trees are cut down and 80 seedlings are planted. Which recursive formula models the number of trees, A to the n, after n years? First of all, I tell my kids, if it's recursive, they have to give you n1. They have to give you a number for n1, and then they give you the equation afterward. It is not just going to be some equation without an n1. That's what recursive means. So choice 1 has an a1, and choice 2 has an a1, but 3 and 4 do not. So I can't even look at those because this word recursive right here. Okay. The second thing is I start with 150. So my first thing is 150. That's good. Okay. Each year, 20% of the trees are cut down. Okay. So if I take my 150, I don't multiply it times 0.20. It is decreasing by 0.20. In here is always 1 plus or minus my rate. I am decreasing, so I'm going to subtract the rate. And my rate is 0.20. 1 minus 0.0 is 0.80. So I'm going to take my previous term. In this case, I'm going to take a to the n minus 1. That means my previous term. I'm going to multiply it times 80%. Okay? And then I'm adding 80 more trees, so I'm just going to add 80 trees to it. And this right here is what you should end up with. All right? Choice 2. I am not only taking 20% of trees. I need 80% of trees left. The 20% of trees are what's going. Just like us, we are going to problem 22. I like this problem, but then I hate this problem. Okay? Which equation represents a parabola with a focus of 4, -3 and a directrix of y equals 1? I love coming up with directrix focus type equations for parabolas. I'm just decent at them. So here we go. Let's draw this. If I have a focus, we'll do this in green, at 4, -3. 1, 2, 3, 4. 1, 2, 3, -3. Here's 4. That's the point right here. This is the focus at 4, -3. Now I have a directrix at y equals 1. Right here is where y equals 1. It's a straight line. It's y equals 1. That's the directrix. Okay. My vertex is always smack dab in the middle. Okay? So how do I get from 1 to -3? That's a distance of 4. That's a distance of 4. Okay? I go 1, 2, 3, 4. Half of 4, kids, is 2. Okay? So here's the middle, because I go up 2 and I go down 2. Okay? So my vertex is going to be at 4, -1. That's my vertex. That's the H and K when I come up with the equation, H and K. The equation of my parabola is y equals a times x minus h squared plus k. My h is 4, so it's x minus 4 squared, plus my k is -1. So we could just say -1 instead of plus and negative. Y equals, so what's my A? A is 1 over 4c. There's so many things to remember here. So what's C? C is the distance. Okay, it's the distance from your vertex to your focus. Okay, so I'm going down 2, that's -2. That's my C value. So it's -1/8. Okay, -1/8. All right, well, I look here, and I like this problem because of what I just did. I don't like this problem because, look, now you got to rip this problem apart. You're not, knowing the equation isn't good enough. They're having you do more algebraic manipulation. Okay. First off, I can eliminate 2 of these problems. I can actually eliminate 3. Oh, I don't. Oh, if we are smart kids, oh boy, if we're smart kids, we can look at one thing. In my equation, you see I have the x minus 4 squared? Whatever equation I have up here should have x minus 4. This is x minus 1 squared. Bye-bye. This is x minus 1 squared. Bye-bye. This is x plus 4. Bye-bye. This is the only one that has my x minus 4 squared in it. If I were to get this alone on one side, the other side would be this. I won't have to show that to you because we don't have to do it. You're welcome. I like it, but I hate it. All right. 23. Mia has a student loan that is in deferment, meaning that she does not need to make payments right now. The balance of her loan account during her deferment can be represented by the function f of x equals 35,000 times 1.0325 to the x, where x is the number of years since the deferment began. If the bank decides to calculate her balance showing a monthly growth rate, an approximately equivalent function would be, if you really wanted to, you could, and some of you, I would suggest this, put this, again, don't I have the blue highlighted up here? I do, kids, and it's green. Oh, that means this arrow needs to change, and I need to go here. I'll just do it this way. You could put this in y1, and then you could put this in y2 and see if it's pretty much the same graph. If it's not, put this in y2 and see if it's the same graph as the blue highlighted one. And then just go right down and see which one's the closest. But let's do some algebra, kids, okay? First of all, x is a number of years. That's the first thing I want to point out, okay? My x is in years, but they want it to be in months, okay? So first of all, 1 year, which is kind of what my x is in, that's equal to 12 months. So wouldn't I have to divide this by 12 to end up being per month? So my exponent isn't just going to be x for 1 year. It's going to take that year and divide it by 12. Or you could say 1/12x. okay, this is going to take my year and break it down per month, because a month is 1/12 of a year. Okay, so let's take this to what we started with. Now, if you notice, all of these start with 35,000. So I'm not even going to consider this yet. I'm going to take my 1.0325, and instead of raise this to the x, I'm going to raise it to the 1/12 x, because now I want that year exponent to be in months, like we did here. So what I'm going to do now is I'm going to take this 1/12 and actually apply it to this base. So in my calculator, clear. Take my 1.0, okay, 325. I'm going to raise that to the 1 divided by 12. That becomes 1.002, and we'll round this 4 places. This will become a 7 because a number after it's 5 or bigger. So 1.0027. So that's 1.0027 to the x. Yeah, I mean, we still have the 35,000 out front. That's fine. Now, this is per month, okay? But this is what I don't like, okay? I don't see that anywhere, okay? This is per month. We still need to make it back per year. So you're going to be like, well, Visca, we just undid it. I know. That's what I don't like about this. This is currently in months. Why is it currently in months? Because we changed our exponent to this. How many months are in a year? 12. So don't I have to multiply it times 12 again to make it a year? I'm going to take my exponent, which is now in months because we did this, and if I multiply my exponent times 12, I will get it in years again. That is crazy. So they want to take my year exponents and apply the monthly growth rate, which is what's in parentheses, the monthly growth rate. And that's choice 1. Yeah, there it is. I was looking for it, and there it is, choice 1. I mean, I don't like this because it kind of like, you know, you guys haven't experienced this stuff yet, and they should do something with like fast food prices or, you know, cell phone prices or data on a cell phone or something, because you guys don't have these things right now, so it gets a little confusing. But the answer is choice 1. Finally, 24, we're going to be done. Which graph shows a quadratic function with 2 imaginary zeros? If they are imaginary zeros, this one's easy. It means they are not real, which means they're imaginary, right? That's what they tell us here, imaginary. If they're not real, it does, oh, I should put an E there, not really touch the x-axis, because there are no solutions. The zeros, or the x-intercepts, are also called the solutions. A quadratic, okay, I'm looking at this, first of all right? I'm looking at this. Quadratic function. Okay, quadratic function. Where the heck's my page? Okay, here, I made notes. Sorry. Okay, a quadratic function. So I can't touch. See how this touches right here? So it's not choice 4. See how it touches right here? It's not choice 1. So look, I see choice 2 doesn't touch the x-axis. That's the x-axis. And I see choice 3 doesn't touch the x-axis. Okay, that's good. So which one is it? A quadratic is a perfect U. That is a degree 2, whether it's open up or open down. That is a quadratic, a degree 2, either one of these. Anytime I have an even exponent that's bigger than 2, okay, it does something funky in the middle. It'll do this, blah, blah, blah. Or it'll go down, blah, blah, blah. It's not a perfect U. Okay, this might be x to the 4, or x to the 6, or x to the whatever. Okay, only a quadratic will be a perfect U. This is not a perfect U. This one is choice 2. We're done. You're welcome. No math whatsoever. I'll see you for the short answer. Bye-bye.
Don't forget to subscribe and ring that bell.